All right, welcome. Today we're jumping into something that's at the very core of the digital shift in our industry, the language of construction data. We're going to decode the standards that are shaping our future, all based on the fantastic insights from the book Construction 4.0.
Okay, let's just start with the question that I know every single one of us has screamed at our computers at some point. You've got your model, your schedule, your site data, so why is it so ridiculously hard to get them all to just work together?
Well, the root of the problem is something you could call a digital Tower of Babel. It's this idea that we have all these amazing, powerful digital tools, but they all speak completely different languages. And this fragmentation, where every software has its own private language, that's the central hurdle we've got to clear.
Now this slide, this really nails the contrast. Think about the internet. It works, right? It just works because it's built on these open, shared standards like HTML. Everybody agrees to the rules, so everything just connects. But in construction, for a long time, we've relied on proprietary standards, owned by one company. And what does that do? It creates these digital silos, trapping our data and causing massive communication breakdowns.
So, here's the bottom line. When our digital blueprints are basically written in a dozen different languages, the consequences are very, very real. We're talking about misinterpretations, silly errors, incredibly expensive rework, and just a ton of waste. To fix this, we need a common language.
And that brings us to the first really big attempt to solve this, a kind of universal digital translator for the whole industry. It's called the Industry Foundation Classes, or IFC for short.
IFC is a really big deal. It's an open public data model, meaning nobody owns it, that's been developed for more than 20 years. Its entire reason for being is to create a common ground, a shared framework, so that all our BIM data can be exchanged and understood by anyone, no matter what software they're using.
And it was really designed to do two main things. First, tear down those software silos and just let the data flow. Simple as that. And second, create a neutral way to archive our project data for the long haul. And that's absolutely critical, right? You need that data to be readable decades from now, long after the software you built it in is gone.
So how's it actually built? Well, the IFC schema is put together in 4 really logical layers. You start at the bottom with the resource layer. This defines the absolute basics like materials and simple shapes. Then you've got the core layer, which defines things like people, processes, and how they relate. On top of that is the interoperability layer, which has all the shared definitions for exchanging data. And finally, you get to the domain layer, which has all the specifics for disciplines like architecture or structural engineering. It's a really smart bottom-up approach.
And this visual just shows you the power of that layer designed perfectly. You have these solid foundations and common definitions that provide a really stable base. Then you can build specific extensions right on top for really complex stuff like rail, road, or bridge projects. It's made to be both rock solid and flexible.
But, and you knew there was a but coming, as amazing and as necessary as IFC was, the reality of using it turned out to be a bit more complicated. It wasn't quite the perfect one-size-fits-all solution we were all hoping for.
And the book puts it really bluntly. The goal of round-robin interoperability, that dream of taking a file, editing it in another program, and bringing it back without losing anything, that goal has been, and I'm quoting here, largely ineffective.
So what does that actually mean for us on the ground? It means that while IFC is fantastic for sharing information one way or for archiving it, that perfect, seamless back-and-forth workflow between different programs, that's still a huge challenge. The translator just isn't perfect.
But you know what? That limitation actually forced the industry to think bigger, to move beyond the idea of a single perfect file. The future isn't about one file. It's about building a whole web of information.
And this change is happening in 2 really key ways that are totally changing how we think about data in construction. So let's check them out.
So the first big evolution is what's called federated data. Now, instead of trying to cram everything into one giant master file, this is all about connecting different specialized standards. For instance, you could link your sensor data, which uses a standard called BACnet, to your building model in IFC. And then you could link that building model to a huge city model using another standard called CityGML. It's about finding the common ground so that specialized data can talk to each other.
The second evolution, and honestly, this is the real game changer, is linked data. The goal here is so simple but so powerful. It's about getting our building data onto the web, just like any other piece of information. It's about turning our data from a static file into a living resource online.
So how does it pull this off? It uses a really simple grammar called RDF. All of your information gets broken down into these little three-part statements called triples. You have a subject, a predicate, and an object. It's just like a basic sentence. This window is the subject, has a height of is the predicate, and 2180 millimeters is the object. Simple.
And this slide shows you exactly what that looks like. Instead of a spreadsheet with rows and columns, your data becomes this incredible network, this web of connected facts. You can see right here that window X is linked to its type, which is FAC window, and it's also linked to its height, 2180. Every little piece of data is just a node in a giant connected graph.
And when you structure all your data this way, you create a genuine web of data. Our building information is no longer trapped in some file on a server somewhere. It's part of the World Wide Web, and you can link to it and search it from anywhere, just like a website.
And this right here, this is the ultimate vision. This is linked building data in action. Your main product info can be directly linked to live sensor data from the site, geospatial data, supplier specs, maintenance records, literally anything. It creates this modular, interconnected world where you can pull the exact data you need precisely when you need it.
So, if there's one thing to take away from all this, it's this. The future of construction data isn't about finding one perfect, giant standard to rule them all. No way. It's about building a smart, flexible network where lots of different, specialized standards can all connect and talk to each other using the power of the web.
And this shift, from thinking in terms of isolated files to thinking in terms of a web of data, that's the foundation of Construction 4.0. And it leaves all of us with a pretty big question to think about. Is your business ready for this new, connected world?
Hey, thanks so much for joining us. I really hope this look at the future of data standards gives you a lot to chew on. We'll see you in the next one.